All right, class. So this is the second part of this explanation video for the practice quiz. If you want to get the answers or see the explanation for the first part, that's this other video that I will link here. In this video, I'm going to talk about these two problems. This is a mole concept type problem, and this is a mass percent type problem. So let's go ahead and get started. The first thing that I would do for this first problem is just sort of read through and pull out any relevant information and then sort of make a plan for where to go from there. So I see a sample of ethanol, C2H6O. I might just go ahead and write out what the mass, what the molar mass of that is, 46.08 grams per mole. I don't necessarily know that that's going to be useful or important. It happens to be in this case, but I think it's just a good practice, right, to start pulling out that information sooner rather than later. It's found to contain some number of atoms of carbon, so we have to really pay attention to what it's telling us there. What is the mass of the total sample of ethanol? This is the question. Grams of C2H6O equals question mark. So I might highlight that for myself as well. So then something that I sometimes like to do is write out 5.46 times 10 to the 24th atoms of carbon, and we want to go to grams of C2H6O. And then sort of think about, well, how could I do this? Almost like retrosynthesis. You know, how could I get to grams of C2H6O from this number of atoms of carbon? You know, what are some things that might be useful? Right away, I can recognize that this mass right here, this molar mass, that's probably going to be important, right? If I want to know grams of C2H6O, if I know moles of C2H6O, moles of ethanol, then I could use this molar mass to figure out grams. I know that there's an atoms to moles conversion using Avogadro's number. But in this problem, there's one extra little wrinkle, one extra little aspect. And I'm going to actually talk about that first. So we're told that we've got some number of atoms of carbon. So these are just empty carbon atoms. And we're going to have 5.46 times 10 to the 24th of these. Obviously, I just have 2 here. But you can imagine I've got a pile of these, okay? And then we're going to make this ethanol molecule. So this right here is an ethanol molecule. C2H6O, if you count up, your carbons and your hydrogens and your oxygen here. So this is my ethanol molecule. So for every one of these, it takes 2 of my atoms of carbon. So we could actually create a conversion factor here where we say, maybe we'll just write it up over here, 1 molecule of C2H6O equals 2 atoms of carbon. So for every one molecule, right, I've got 2 carbon atoms. So I can use that to convert basically this number of atoms of carbon into number of molecules of ethanol. So let's go ahead and do that. 5.46 times 10 to the 24th atoms of carbon times 1 molecule of C2H6O over 2 atoms of carbon. So my units of atoms of carbon will cancel out, and after I do this calculation, basically I'll have now, instead of how many total carbon atoms do I have, I'll have how many actual molecules of this ethanol do I have. From there, I would use Avogadro's number to convert into moles of C2H6O over 6.022 times 10 to the 23rd molecules. So mole is just a count, right? Molecules of C2H6O. And then now I can just convert from moles, right? So this units will cancel here. I'll be left with units of moles of ethanol. And I can use my molar mass now, 46.08 grams over 1 mole. Units of moles will cancel. And I can just run through that calculation, and I should end up with 209 grams of C2H6O if I just run through that whole calculation there. So basically just unit conversions, right? We're just going through canceling out our units. When I did see some people giving this problem a shot, I noticed a lot of times that units sort of fell away, right? Once they stopped being convenient or once they stopped really making a lot of sense, then people just gave up on them, right? That's a surefire way to make sure you're going to get it wrong, right? We want to make sure that our units are making sense all the way through. All right, 209 grams. For the second part, this is really a mass percent problem. So cobalt is mined from cobalt-3 oxide, CO2O3. We've got our ionic formula here. determine the mass of pure cobalt in a 943 gram sample of cobalt-3 oxide. So basically in this problem, I can recognize this as a mass percent problem pretty quickly because we're asked to find how much pure cobalt there is in this 943 gram sample. So if I want to know the mass percent of cobalt, that's going to be the mass of cobalt present divided by the total mass. And if I want to convert to a percent, I'm going to multiply by 100. We don't actually need to do that in this problem, but just to illustrate that. So cobalt-2, I'm going to first find the mass of the whole thing. That's 165.86 grams per mole. And out of that 165.86 grams for the whole cobalt-2, 117.86 grams is from the cobalt, right, of cobalt. So that's CO2 actually, so I'm going to use both of the cobalts there because it's, the total mass of cobalt divided by 165.86 grams. Let's go ahead and multiply by 100 so we can talk about that percentage, 71.1%. So this percentage here, this is the mass percent of cobalt in this cobalt-3 oxide. So basically what it says is that for every 100 grams of cobalt-3 oxide, 71.1 grams is going to be made up of cobalt. So to solve this problem, determine the mass of pure cobalt, I'm just going to utilize this 71.1% by multiplying it by my total mass of 943 grams times 0.71. I'm going to use a whole number here. So on my other paper here, this 0.7106, that's what you actually get from this calculation. I round it to 3 sig here, but we want to use all of our digits if we have them. So 0.7106 equals 670 decimal point grams of cobalt. So that is my final answer. Just using a mass percent to figure out, well, if this is how much my sample weighs, 71% of it is cobalt. This is the mass of actual pure cobalt that you could get from this cobalt-3 oxide. All right, hope that helps. Definitely let me know if you've got any other questions. Cheers.